Okay, problem 4. Now we're going to subtract expressions with different denominators. Alright, so we're not adding anymore, we're subtracting. Now, something that I think the book doesn't do a very good job about is if you look at the title on problem 3, it says adding expressions with different denominators. But in adding, they only showed you examples with monomials. And then when they do subtracting, they do examples with binomials on the bottom. Well, just so you know, you would add the same way you would subtract. You just want to have, with binomials, you just want to have to distribute a negative with your adding. So just understand that this is really more or less what to do with binomials. The minus sign always just gets distributed. In problem 4, we need to come up with a common denominator. The common denominator is what are multiples of the ones here? Well, these are completely two different things. So your common denominator, again, is the least common multiple. But because these binomials are completely different, your least common multiple is d minus 1 and d plus 2. It's both of them together. I'm going to carry it over. So when it's binomials, unless they're the same, you need to bring them both over. And they need to be exactly the same. It's not. Now we need to figure out what's missing. Well, this d minus 1 needs a d plus 2, and this d plus 2 needs a d minus 1. Alright, same thing for the top. Whatever the bottom's missing, the top is going to need. So this becomes 3 times the quantity, d plus 2. Now here's your minus sign. Be very careful with it. It's minus 2 times the quantity, d minus 1. Now some of you who like to kind of skip steps, you might be wondering, why didn't I distribute at that step right away? The reason I didn't distribute is because sometimes when students distribute, they forget that it's actually a negative 2 that they would be distributing. Let's combine our like terms. If you're wondering, I guess I didn't color code those. Those would be the orange things. So this becomes 3d plus 6 minus 2d plus 2 over my common denominator, d minus 1, d plus 2. Now we're going to combine our like terms on the top. 3d minus 2d is d, and 6 and 2 makes 8. Because the bottom's already factored, I just need to check if the top factors. Does the top factor? The answer is no. So our final answer is d plus 8 over d plus 1 and d plus 2. Number 4. We got it, number 4. Your common denominator, again, is your least common multiple. Since they're binomials, you have to include both binomials. So when I write my equal sign here, I'm going to do 3c minus 1, c minus 2, and I need to figure out what's missing. This is missing a c minus 2. This is missing a 3c minus 1. If it's missing it in the bottom, it's missing it in the top. I'm going to write it before I distribute. C times c minus 2. Notice I'm going to wait to distribute just in case there's something I might easily miss. Minus 4 times 3c minus 1. Now I distribute. C squared minus 2c minus 12c plus 4 over 3c minus 1, c minus 2. Combine your like terms on the top. C squared minus 14c plus 4 over 3c minus 1, c minus 2. Now this one's kind of tricky. It looks like it factors. But in all reality, this problem does not factor. There are no factors of 4 that would give you, let me say it again, there are no factors of 4 that would give you a 14. So in this case, we leave it alone because it's not factorable. Moving on to example 10, I wrote on here that the factors might need to be factored before you begin. So let's look at example 10. Does anything need to be factored in example 10? Answer is no, nothing needs to be factored. So I get my common denominator, and my common denominator is x and x plus 2. Because this is a monomial and this one's a binomial. So they're completely different, which means that I need both of them. Now, what is the 2 over x missing? Again, the question is, what is the 2 over x missing? It is missing the x plus 2. The x plus 2 is missing an x, so the 5 needs an x. Carry it over. And you're going to get 2 times the quantity x plus 2 minus 5 times x. Distribute in, so you get 2x plus 4 minus 5x all over x times x plus 2. Combine your like terms on the top, negative 3x plus 4 over x times x plus 2. I could, if I wanted to on this one, pull out a negative and make that 3x minus 4. Do I have to? No, because it doesn't help me necessarily simplify, but it is helpful just in case in the end it would have simplified. So if your first term is negative, I'll encourage you to pull a negative out, but if you don't have to, it's not necessary. If it doesn't help you factor or reduce at all, it's really not necessary. Okay, example 11. The bottom left needs to be factored first. That hasn't happened yet in any of our problems. The bottom left needs to be factored into a and a, 3 and 2, minus and plus. The reason I do that is so that it will help me get my common denominator. My common denominator in this case is always both from the first fraction, if there is one, and anything additional that the second fraction brings. Does the second fraction bring anything that we don't have? No, we already have an a minus 3, okay? So we don't need to bring it over. Now we figure out what's missing. This denominator is good. It's not missing anything. Therefore, the numerator is good. This denominator is missing an a plus 2, so this numerator needs an a plus 2. Your new numerator is a minus, now watch how I'm going to do this. I'm going to do minus 3 times the quantity a plus 2. And that's over my common denominator of a minus 3 that I decided an a plus 2. Distribute in and then combine your like terms. Bottom stays the same. The top is a minus 3a minus 6, which turns into negative 2a minus 6 over your common denominator that we had. Now for the last step here, what we're going to do is we're going to take a look at the top. On the top, I can factor out a GCF. You ready? I'm going to pull out a negative 2, and that's going to leave me with a plus 3. Now the question becomes, can I reduce it all? Since I pulled out the negative 2, can I reduce? Well, I came really close, didn't I, to being able to reduce with the a minus 3. But I can't, so my final answer is as it stands. Example 12. In example 12, you should notice that this bottom right factors to 2x and x, and I'm going to guess a 3 and a 2. Get your signs on there so it works out. going to put a minus there and a minus here, or a minus at the 2 and a plus at the 3. So I get a positive 3 and a negative 4, which gives me this negative 1. So I factored the bottom right. This bottom left doesn't factor. My common denominator comes from the first and the second fraction. So the common denominator in this case is 2x plus 3 and x minus 2. Notice I only brought one of the 2x plus 3's into my denominator. Now we need to see what's missing. This is missing an x minus 2, so the top's missing an x minus 2. This one has both, therefore the top doesn't need anything. This is 5 times the quantity x minus 2 plus 3x minus 13. No need for parentheses because I don't have to distribute anything in. So I get 5x minus 10 plus 3x minus 13 over my common denominator, 2x plus 3, x minus 2. I'm going to combine my like terms and get 8x minus 23, which is kind of nice because it doesn't factor, over my common denominator. Because it doesn't factor, because it does not factor, I put an N there for no. I leave it alone, and it is what it is. We're going to do example 13, and then we're going to stop, and I'm going to want you to try the challenge problem on your own. This 2 is technically over a 1, so when I get my common denominator, I don't really need a denominator for my first fraction, but I do need the x minus 1 for my second fraction. So this one is missing an x minus 1, so the top needs an x minus 1. This one has the x minus 1, so the 5 doesn't need anything. The 2 goes with parentheses with x minus 1, and then you keep the 5, and it didn't need anything. So we get 2x minus 2 plus 5 over x minus 1, and then we get 2x plus 3 over x minus 1. Nothing factors, nothing reduces, so I'm all done. So the main thing that I can kind of send home with you is at the end of your problems, factor if you can, and you're only going to really be factoring the numerator. Because if you can factor the numerator, you might be able to cancel or reduce. Okay? So you're going to factor the numerator if you can, and then after you do that, you're going to see if you can cancel or reduce with the denominator. And only do that if it's possible. Alright, good luck on the challenge problem. We'll go over it when we come back to class together.